let's do it.
Has anyone brought up Python yet? Because what Adafruit is doing with their
MicroPython.
well, their own particular version, but also MicroPython as a tool for standalone development.
I had MicroPython running, and then the Team Oz sort of took it over, like was doing a native port. So I stopped work on it, but I think they got something working, but I haven't heard.
Okay, well, let's talk about that too then today. So first off, we'll just start our meeting. So we have a time and date on the YouTube video. It's February 15th. Thank you, Tom, for pointing out my confusion in the email. You're the only person that caught it. Thanks for reading. And yeah, this is our Propeller Live forum, and we have a very loose agenda today. So we're going to be talking a little bit about briefly the changes Chip has made to Pnut, I think, and then where Jeff is with an updated Propeller tool. And then we'll be talking about Raspberry Pi stuff. So I think we can move through those tool issues kind of quick. So that starts our meeting.
The strip FlexPin exe is exactly 1.44 megabyte. How curious.
Oh, it'll fit on a 3.5 inch.
Yeah.
And that's probably built with without any optimization. The default.
Oh, that's built with -OGG. That's always what I give it as the option.
That's practically no optimization. I think if you compile with -01, it'll get down to about 800K or so.
I guess you have OS as well if you really want to.
Or OS, yeah.
And if I run this for like zip compression, what does that make it? Well, 527K. That's okay. That's probably fine.
Read an article years ago, verified it myself. If you do -OS, lowercase s, optimized for size, a lot of binaries run better because they're all in cache. Or more of them are in cache. Surprising.
Yeah, that's a funny thing that can sometimes happen, is that making the code smaller but slower actually makes it faster because the cache is more important than whatever weird thing that the compiler did.
So before we go into that, Chip, could we just briefly talk about whatever changes you've been making to Pnut that are coming?
Yeah, can you hear me okay? Is this
Yeah.
mic? Okay. It's funny, I was talking to Tom just before I got on here, and good thing he's here too. Okay, so let me just go to my list of changes here. There wasn't a whole lot. There was a bug from v37 that didn't allow parent object con blocks to use con symbols from child objects. So what I had to do is add a few more passes to the con assembly, so that after it pulls in the cons from your child objects, you can then incorporate them in your con statements in your parent object. So that got fixed. And then there was that bug that had been introduced, which caused rot XY, pole XY, and XY pole to not work right. And it's because I just forgot to put a pound sign in front of what was intended to be a constant. I didn't know that, so that got fixed. And then we backed up the repeat var behavior so that after a repeat var loop is done, the final value of the var is the terminal value plus minus whatever the step was. So this makes it easy to detect. You can do like, are we greater than the limit when you come out? And you can then determine if the loop aborted early. So because I even had some code that was hurt by that change where we had made it earlier so that it would end with the terminal value and not the terminal value plus the step. So anyway, that we shouldn't have changed it back when, but it seemed like a good idea. But anyway, so that's back. And then we just have gamma corrected alpha blending in all the debug windows for anti-aliasing, which is a minor cosmetic issue. So that was it.
Speaking of the debug window, have you ever noticed that the little dots for the memory and the RAM contents they are not actually all the same size. It's very, very obnoxious.
You know why that is, right?
It's because there's like some rounding problem, I
Yeah,
guess.
it's because we're doing a stretch draw from like a pixel level canvas onto the display. So, you know, some pixels will be 2, and then you get 2, 2, 2, 3, 2, 2, 2, 3, and something like this. So it's not matching up 1 to 1. So yeah, it looks.
I think it's sometimes even worse than that. Like something very strange things are going on with that.
I wonder, you know, I could actually do, you know, the way to solve that could be just to use my own, well, let's see, I don't have, no, I do have thickness control to a 256th of the pixel. I could use our own plot functions and probably get around that by using the anti-aliasing. That's
You probably
probably
asked me how I noticed weird things like that. I have a funny thing that I made. If you haven't seen it, I'll show it later.
Oh, I know the animation that you did. Yes.
Very interesting use of debugger.
Yeah. A first for sure. Yeah, you know, I could use correctly sized pixels and allow it to anti-alias them when it draws them. That would be the way around that. That wouldn't even, well, it'd probably be slower than whatever Windows is doing, but I'll try it out. There's a 64 by 64 array of pixels, you know, kind of virtual pixels there. So that's going
I think it's
to
actually
take,
64 by 62. I don't think it actually has the area for the debug RAM.
Yes, because I didn't cover the last 16K because that
That's
is
boring.
the debugger and there's no reason to be looking at it. Yeah, so it's 64 by 62. So it's like 4,000
Also,
something.
the checksum is kind of funky. Sometimes it doesn't realize that you changed something.
The checksum. Oh, is it really? Because it should, it's doing
Yeah,
it. Okay.
I've specifically made the animation code change it with like a linear feedback shift register type set up specifically because just incrementing a byte, sometimes it just wraps and doesn't notice that an entire like
Yeah, if
8K
within a
block has
range,
changed.
if you incremented 1 byte and decremented another, I think that would cause it to not see a change.
Yeah, the way I've done it is that for each block in memory, there's the first byte in it is special, and that it's not used for data and it's just incremented when I want to light that pixel up.
Okay, I could come up with some better thing. I mean,
But incrementing it didn't work properly. It was glitchy, so I made a more complicated way of changing it, and that mostly fixed it. But you can still, if you run the thing, you can still sometimes see like a black horizontal line, but it just doesn't notice that the entire like 8K block or 4K block or whatever it is, it just completely doesn't notice the change.
yeah, here's the thing where it computes the sum. It's kind of a thing that can you see that?
Yeah, that's the one.
Yeah, so I tried to make it kind of crazy and random, but
I think just putting random patterns doesn't actually make it better.
yeah.
I'm not entirely sure what would make it better.
You see the point here is that each time it deals with one long, it's just a 2 clock instruction. That was the I did these so that there's some you know, continuity from data to data.
I think the problem is because this is a block of some power of 2 sides that it works.
Right.
When it goes over the first thing in the block, and 1 has incremented, and 2 have incremented, but the C state is different when it goes there. It sort of cancels each other out, I think.
Yes.
This would perhaps.
I could just change this to a simple checksum where I simply
trying
add.
to look at this. This is actually no. This is. I think your weird problem is that you might need to shift it after each block. That might perhaps make something happen. You shift
Okay.
it after each block.
This to me feels like the prototypical example of why you never write your own crypto.
Yeah, right.
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 Yeah,
Yeah.
I would just change it to a checksum.
Okay,
which
well, that
isn't
would just be
so
like,
based, but it's
know-
certainly probably better, more thought over than you have it. I thought you had, don't you? Oh, that's on the PC.
it would look like this then, and I could get rid of these WCs. We don't need those.
But if you rotate it by one after the whole thing, I think that will maybe make it better.
Okay, let's see. Okay, so there we go. Now we're just adding. Oh, wait, this first one has to be. Oh, I did a move here. I could have just, oh yeah, we want to initialize PA to 0 and then add, because this thing here loops. So we want to keep adding. We don't want to do an initial move. We want to just do adds all the way through. So what do you think could be done to help that a little bit?
Yeah, maybe a rotate after each ad, right? That fixes.
I mean, just to rotate after the block makes it better a bit.
Should the rotate go here?
Presumably, yes. You rotate. I think rotate right is probably better. If you rotate right by 1 bit.
Okay. Yeah.
Oh wait. Don't we have this funny instruction? Like the SUSEF or whatever it was called. That's better than a rotate.
Oh wait, here we're doing. There's one last thing that was happening here.
Instead of the rotate, make it like the SUSF SUSEF. Make it that.
Oh, the SUS.
Finally, a use for the funny.
There we go. Now we're back to what Tom's talking about, but how many should we do? How about 9? Now 11's a bad number.
That one doesn't even take an argument.
Oh, it doesn't, does it?
No, it doesn't
You're
take
right.
an
It
argument.
doesn't. It would just be that. Okay, now that I say get word. Oh, okay. And then what it does is it brings them together. So here it sums the upper and lower word and then sends it out. So it's a word checksum.
Well, the obvious thing to do now is to see if it works properly.
Yeah. Oh, it will work. It'll work differently. Okay.
That's
Well,
for
anyway,
sure.
I'm going to save this. That's going to be the new debugger then. Okay.
Should we move over to Jeff right now, Chip?
Yep. Let me stop sharing here.
Can you guys hear me okay?
Yep.
Okay. I'm going to share my screen real quick here. All right, so a couple of weeks ago, I think it was, Chip released Pnut version 38 with these compiler changes that he just mentioned. And here's kind of a list of some of them. Can everybody see my screen?
Yep.
Okay. So he just talked about these fixes. And so now that's incorporated into a Propeller tool that was released today to 2.9.3. In addition to that, there is also this item that I did, which I had mentioned in the last session, I think, and I'll just demonstrate here that the parameterization feature where you could have like this child object here that declares a couple of constants. You can manipulate it at the top level from the parent object by doing something like this. So instead of a multiplier of 2 and a count of 1, I could make it multiplier of 3 and a count of 5. When I run this, I guess I should have run it without that change. So you see what it originally would do. So it just outputs one iteration of a little loop here where it's multiplying by 2 each time.
Hey, Jeff, could you make the debug output bigger anyway? What controls the
Can I do that? I don't think I have any control of that.
Oh, because what I use what is, I think, a variable called font size. And I don't know how your tool uses that.
You can, I didn't even know that you had it set up so that you could change that. So I haven't integrated that in any way. So I think the answer is no at the moment.
Okay.
I can change the size in my editor.
Oh yeah, you should be. Yeah, well, see, the way it works in Pnut is the size of the editor text is used for the size of the debug text.
Hmm.
So it just
Okay.
copies whatever size you have.
I'll have to look into that.
Chip, are you sure that font size isn't only on the text debug terminal? Because I was looking at that, you know, how fussy I am about output.
All right. Wait, ask that again. I didn't understand the whole question.
Well, I was wanting to do what you just asked Jeff, to make the standard debug screen have a larger font. And I don't know that you can do that unless, well, it's not, I'm not using Pnut though. That's probably the issue. I'm using
Oh,
the color tool. But the font size that you just mentioned, I think that's only in the text debug window.
This one right
Yes.
here.
Correct.
yeah, it's the text.
No, Jeff, there's a debug window type that's called terminal. Sorry.
Oh, yeah.
Yeah, so that you can control the font size very easily in that,
But not in the native debug output.
but not in the native debug.
Okay. Well, I'll look into that and see. I had actually wondered that a long time ago and then never posed the question. Never looked closely enough at the code, I guess, to see that. But anyway, the point is not, you don't really have to be able to read this closely. But I just wanted to demonstrate that here I have two references to the same physical object called child 2 in this case. Each one starts a cog and runs through this little routine, but I've modified the behavior of the first one. And now when this is displaying what it did without the modification. Now, if I run it again, you'll see that the first one iterates 5 times, which is this count value that I changed, and by a multiplier of 3. And also you can, this wasn't working quite right last time. So if I had done this, I think it was pretty clear last time that it wasn't behaving properly. It was only taking whatever the last compiled object was and whatever constant manipulation was happening and applying that to both instances. So Chip and I talked about it, figured out what we need to do to fix that. So I've fixed it in Propeller tool.
Awesome.
Could you show us the child 2 code again? Gotcha.
Wait, say that again, Stephen?
Nope, nothing. I was just looking to see what it looked like.
Incidentally, over here in the little object view, if you look at this, when I select this, you can see that both these objects are highlighted. That's an indication that it's exactly the same file. In this case, in fact, if you point at it, it'll show you where it's actually located, and you can see that they're both the same file. However, if you compile this and bring it up on the info display, remember that this one's been modified from the parent.
Mm-hmm.
Now, when I go here, you can kind of see the same thing. They're both highlighted, so they're the same physical file. But if you watch right in this area here, this is showing you right now what that particular object would look like if it were an application by itself. And if I click back and forth, you'll see, hopefully you can see that on the screen, that a couple of the values on that last line has changed.
Wow, that's pretty fancy. That's nice.
And then, of course, in the upper level, that's all incorporated into the object here. So I think during the last session, when I ran something similar to this, it was showing the code size was something like 104 bytes, because it was only using one physical instance of that object. It had optimized the other one out inadvertently. So now that's fixed. And that does it for what I wanted to show you.
Good. Well, that's good. You got all that solved. If you guys remember, what was happening was the compiler was spitting out one OBJ after another with the same name, and then picking up the last OBJ file to compile at the next scope level, and it was only getting one change. So now, so what Jeff had to do is make it so it saves or puts into memory different, like differentiated OBJ files, so it picks up the correct one as it goes back up to the parent.
Yeah, that's kind of funny because how this works is the compiler itself just kind of deals with a little small piece of the application at any given time, and when there's multiple files involved, the editor is feeding it different parts of the branch of the whole application, and all the branches and all the way down to the tip and everything. And what was happening is that at the top level, it was seeing that there were multiple objects that were named the same thing, and it was just grabbing the last object, the last binary that matched that name, and feeding that as the that piece of the object that was called for, or that piece of the whole application. So it's been doing that since 2006, but it didn't matter because the code was always the same. So this change that Chip made actually exposed that what wasn't a bug before now became a bug.
Can I ask a clarifying question then?
Sure.
Does this suggest that Pnut does or does not compile Jeff's example?
Currently, it'll fail in the same way that the Propeller tool was failing last month.
But you just fixed that though, right?
I fixed it in Propeller tool.
Right, but I have to do something separate in Pnut because this is a Delphi level thing. It happens in the Pascal code, not the compiler.
I think it'll be a lot simpler, Chip, to fix it in Pnut than it was in Propeller tool. When we were talking about it, we decided, we can just do this really simple little name change in the structure. But it turns out I couldn't do that because Propeller tool allows you to have unsaved code that's just open in a tab, or saved code that's saved to a folder, and it could be in another folder, it could be in the library folder. And so throughout the recursive compilation process, it really needs to keep track of the full name of the file, or the full name of the object, and potentially the path that it belongs at, or the fact that it's just in an editor tab. So what I ended up doing is not, it's the same thing that you and I talked about, it's just a little bit more elaborate.
Yeah, well, that's nice. You can differentiate it in that screen where you can look at it object by object and see. I don't have any utility for doing that.
Thanks.
When Chip fixes Pnut then to accomplish this, is that going to interfere with your fix, Jeff?
No, because that's in the Delphi code for the editor component in Pnut, which I don't use that same component. So out of the Pnut project, I'm only using the debugger units and the compiler.
Jeff, there's a question in the chat from Robert. I'm having problems with documentation not compiling on 292. Will it be good after an update?
Documentation not compiling. Oh.
This is the little
that.
text file.
Yeah, so like this, he's talking about there's no documentation in this code, but I wasn't aware that there's a problem. Maybe he can send us an example.
Oh, is 2.9.2 the very latest?
Well, not as of today. Today it's 2.9.3.
Okay.
But I did not do anything that would have affected documentation that I know of in this latest version. So if he's got something he can point out that's a that I could duplicate, then I can trace through it and see what's going on.
Good. So before we move on, I was interested in just throwing out some topics about the Raspberry Pi, but I think first we should see if anybody has any technical questions that they're hanging out for or requests that we can answer right now, so they can get on with whatever projects they are working on.
I had a kind of a question related to the changes that Jeff was showing. Is there a way to get a listing file for the bytecode?
Oh, currently there isn't. No, I was actually talking to Chip about that I never did implement that. So it's on the list of things to.
You mean for the spin 2 stuff?
Yeah. Yeah,
Well,
showing what.
It's in the interpreter.
No, I mean the generated code, like to see the bytecodes that the compiler.
Like a disassembly or something?
Yeah.
Yeah.
In Pnut, you have that ability and the compiler generates it, but I never attached to that in the Propeller tool. So there's no way to generate it in the Propeller tool.
Does Pnut actually produce a disassembly of the?
No, not a bytecode. It'll show you the raw bytes, but no, it doesn't break it down. I mean, that would be kind of cool to be able to see, oh, these 3 bytes comprise a constant that's going to go on the stack. And then this one reads a variable. Then this one does something with those 2 values on the stack. That's what you'd like to see, right?
Yeah.
I see, Eric. I was misunderstanding what you were talking about.
Yeah, that's kind of cool. That would be nice to have, but we don't have anything like that now.
The FlexBin P1 bytecode compiler does have something like that, but it sucks. Like it looks weird and no one likes it. So I have one that I can pull up.
Yeah, I think OpenSpin and BSTC did that kind of thing too.
I don't think OpenSpin had it either. BSTC had one, and did Homespun have a listing? I forget which ones have which features. But they're all strange and they'll make you.
Well, they're not official.
You know, it would be really cool to be able to show like kind of like a disassembly for assembly language where you have like spin code on the right and then the bytes on the left, so you can see what created what.
Yeah. Okay, well, something to add to the to-do list.
Yeah.
There we go. That's what it looks like for P1 bytecodes.
Oh yeah.
Actually mental and like bigger and get rid of the terminal. No, terminal, go away. It really just looks like this, and it's a bad example. Can I get a bigger one? I want a bigger one. Give me one that would make me less sad.
I mean, this shows what the kind of thing we're thinking of, though.
There we go.
Yeah.
That one has a bit more to it. I think I came up with all the names for the things myself, and they're certainly not the same that come out of BSDC, because one that BSDC uses are weird. So this is
the P1 Yeah, P1 bytecode, right?
Exactly, but P2, the spin 2 bytecodes aren't all that different. I've been thinking that it's probably not that difficult to add support for them into the existing framework, but I'm too lazy to ever do it.
Yeah, and I've been working on the other bytecode interpreter, so.
Yes, it now works for some stuff, but it still does not work for the upper code, for the emulator. It's very strange. I haven't looked that much further into it, but it just does nothing. It's like that, it does nothing. I've even tried at some point to put a print near the beginning and it did nothing, but I'd have to retry that after the changes that were made.
You know, we use byte granularity here because we have hardware like read byte or RF byte in P2. But what if we had like a thing where you can actually declare how many bits to read, or maybe even have some kind of thing where you say, read the next, and it'll like read some variable bit length value all at once. That could make things like this even faster and more memory efficient.
Funny hardware Huffman tables.
Yeah, yeah. Or maybe just make some kind of encoding system that doesn't have to have any library. It just you know, looks at the first few bits. So, and maybe you can configure it to like, you know, use like binary patterns 00 through 10 as like, you know, three unique 2-bit things, and then 111 will always have to precede anything that's longer than that. Or you could kind of like,
well, getting just a number of bits would be very useful. Just like get 3 bits from the thing or something like that. For the funny debugger animation bad apple thing, I've used rice codes in a kind of odd way. Basically, each code is the distance to the next pixel that needs changing. And whenever it wraps around the screen, that's a new frame. And that's how the bitstream compression for that works. It's kind of bad, but it's good enough.
Yeah. Well, it's kind of opens some interesting possibilities of having, you know, kind of a what would you say, a dictionary-less way to just with 1-2 clock instruction read some next data, some next term that could have required any number of bits, but it self-describes how many bits it is. So that way,
the problem with rice codes is that they get sort of linearly bigger.
Yeah.
So because it's basically you divide the number by something, in usual case a power of 2, so it's easy. Then you store the result of that division is basically stored in unary. So the more ones there are, the bigger the number is.
Right.
And the remainder is then stored as a normal binary sort of remainder.
I think RISC-V does that for its instructions, doesn't it?
Yes, there's a prefix for the 16-bit and 32-bit instructions. The first couple of bits tell you which kind of instruction it is.
Yeah.
You could probably make a decent sort of compressed instruction set for potential future P2 version that's still backwards compatible if you just made it so that if some special mode is set, instead of some of the effect combinations don't work anymore, and they instead make a 16-bit opcode happen.
Instead of
problem
X
is that
oh, go ahead.
Except that instead of having to do that, instead of having to no, okay, my sentence just broke off. But basically the idea is you have a bunch of condition codes that are like rarely used, especially if you have like this simple compiled code. What you could do instead is you could reuse all these encodings and turn them into something else. The problem is that that the condition code is in the last byte, so you'd have to look ahead a bit to know that. I guess the option would be to just store all of this code in reverse, which also stops you from accidentally encoding, executing the wrong kind of code. Just something I've thought about for some point. The problem is that these short instructions would then be limited to like 16 registers or something, which would have to be decided which ones that are. Not sure if the first 16 would be better than the last 16.
Right. Okay, well, we can do some kind of disassembly in the future.
Right, so back to the other question. Does anybody have any support questions for Chip, coding questions?
John was talking about Get CRC.
Okay, you saw that.
I've got I think quick one, not very technical perhaps, more documentation. Everybody remember that? The HDMI board for the QuickStart?
Yes.
I can't find documentation for it. Schematics and whatnot.
Oh, we've got it. Can you just drop me an email and I could find that for you?
Sure.
Shannon? Okay, I'll just put my email in the chat right now.
I don't even recognize that thing. What is it?
That the human interface board, two PS2 inputs, VGA audio. It was I bought Radio Shack, so that dates it.
Okay.
Somewhere
And
around
I
2008.
used it once, yeah, a long time ago, set up a demo on it and running VGA, and I, oh, that's pretty slick right there. And I kind of want to set that up again with a few other things, but
Can you just tell me the part number on that board?
Not if it's on the bottom.
Might be on the top.
It's
Either.
the big label, Human Interface Board for QuickStart.
Sounds like
Oh,
it's
here we go.
40,003.
4,003.
Okay.
40,003.
Yeah. All right. Hey, Jeff, I'm having VPN trouble, so maybe you can go to the product folder and grab those resources for Shannon.
All right, I'll start looking that up.
Yeah, and Shannon, send me a message and I'll get them over to you. So schematic,
Excellent.
any source code examples, you could just give them the whole product folder.
Thanks.
Sure.
Hey, Brian has a, we'll get to the Get CRC, but Brian has a question about gamma correction. Brian, you there?
He has audio trouble usually with his Linux box and Zoom.
I can just go over briefly what it constitutes. Before we were doing just linear alpha blending between two colors, which is like, you know, X% of, for each RG and B component, you have X% of the first color plus 1 minus X% or 100 minus X% of the other color. And so those two would, and for some cases that works fine. So what you do is you'd take a percentage of each, and they're kind of complementary percentages. The trouble is when you have a color that's like all red versus all blue, and you try to go between them that way, you get a lot of darkness in the transition. So what gamma correction does is it takes both of the initial color, the two colors that you're blending, it squares them both. Then it does the percentage mixing, and then it takes the square root of that. Yeah, and so the gamma is 2.0, and I found I did 2.2 first, and it just didn't look right. It's like there was like funny stuff going on the edges because it was like over bloating the situation. But 2.0 works perfectly on my screens and my video systems here. So I'm just squaring and then square rooting, and that's nice because we have that in hardware. You know, doing a power of 2.2 would be more complicated. Does that answer your questions, Ryan? Oh, he said yes, helpful. Okay, okay. Yeah, so fortunately, the easiest gamma correction happened to also be the best gamma correction. Okay, so John, get CRC.
And did you see that code that I sent you?
Yes, I didn't look at it too carefully though. I need to review it. I kind of looked at it, but I was doing some other stuff, so I didn't give it enough attention to really understand it. Where did I put it here?
What I did, I went to a couple of different websites, and one had tabular data, so it was easy to copy and paste and reformat into a program. And the short of it is that Get CRC doesn't have enough inputs to be kind of general purpose.
Right, right.
And interestingly, of all the test data in my program, it fails on every single one of them. On what I did is I took your code from the interpreter, put it in, and then added the other inputs from the table, like, you know, if you're reflecting the data in or reflecting the data out, there's an XOR thing, and everything works except 3, and I can't account for those 3 conditions. But the same data on 2 different CRC test sites gives the result that neither my code nor your code matches. So, you know, it was really cold here on Saturday, and I just went down this rabbit hole. I don't need any general purpose CRC stuff. But, you know, it was one of those kind of fun exercises. But, you know, I don't want other people to get trapped in it. If you go take a bunch of data and stick it into one of those CRC test sites with the same polynomial you're using with get CRC, you're not likely.
Oh yeah, well, yeah, I've noticed they often reflect the polynomial. All kinds of stuff's going.
Yeah.
There's all kinds of like bit reversals going on in these implementations.
Well, and the sites will, well, the site that I used for the tabular data will tell you what it's doing with input and output reflection. The other one, and I have both of the links in the code. The other one you can select, like, you know, I use Maxim CRC for laser tag, and when we do projects with John, you know, because we're doing, you know, fairly small packets, and so we don't need anything really super complicated. But when you select a known type, it will show you those things, and then it will let you override them. You can click on custom, and you can change the input and output reflection, or the XOR, or the initial value. Interestingly, the initial value is not always 0 and not always you know, all ones. There are that have completely on. Now the code that I did was, you know, it's just doing kind of like what get CRC is. It only works with things that are byte oriented, you know, like I think you were saying there's a 5-bit CRC and USB, and somebody in a long time ago when I was playing this, trying to get, you know, my head around inline code, somebody said, oh yeah, here's my 5-bit inline CRC for USB. And I think it's using CRC nib and CRC bit. So it's going to be hard to make a singular function that works with everything. But anyway,
yes.
I sent you some code as some ideas, and honestly, there's so much going on, it might just be worth pulling get CRC out of the interpreter and just making a really nice example, you know.
Right. No, yeah, I've thought the same thing. I think you should get rid of get CRC and rename it as like CRC byte array or something. But some things can be inferred, like based on your polynomial, the number of bits of the CRC can be inferred by the leading bit position. Because there's no sense, you're never going to have a polynomial bigger than the CRC size. The polynomial kind of defines the CRC size. I mean, would you agree with that?
Yeah, but if you look at the tables, sometimes it's smaller. For example, there's a standard CRC8, it's just a generic name. The polynomial is 7. So that's
okay.
3 bits, but it's an 8-bit CRC.
But you have to, I bet you anything though, that in order for that to work, you have to reflect that 7 so that it becomes E0 hex. Otherwise,
according to their table, you don't. So you'll see in the latest version of the code that I sent you, there's a table value called Rio, which is reflect, and then it's input and output. And for that particular CRC, neither of those things are reflected. Now, I think because of the way that CRC nib and CRC bit work, you sometimes have to do that. I have a note in my code that I always reflect the polynomial because, and I think it's just based on the way CRC nib works.
Yeah.
And some of this was all empirical. That's why I said, you know, I got the code working well. You know, like I said, there's those 3 examples, and I thought, all right, I'm going to send it to you since we'd been talking about it. But you know, it became a thing. You know, John and I were talking the other day about a new project, and the topic of get CRC said, don't use that in new projects because it doesn't match with the way that we've been calculating 8-bit CRC in the past. You know, luckily we can do that in a few lines of inline code and it works fine.
Yeah. Okay. I wonder if what we call reflection is to them not reflection, like as far as the poly goes, because if you only have 5 bits of poly, I mean, to say that you have the value 07 hex and that's an 8-bit, they'd have to reflect it. Otherwise, you would literally only, the way I'm computing it, you would only have a 3-bit CRC. Those upper bits would be there, but they wouldn't be changing. They would just be scrolling off, like just shifting right each iteration. Or
Well, and
shifting
it
left.
could be, I started looking into, I thought, well, let's just see what algorithms they're using. And then it just got more involved than I cared about.
Yeah,
But it may be they are doing a right shift, and maybe CRC nib is actually going the other direction through the carry.
Yeah.
31 out. Because
I
I
think-
noticed, I'm sorry to interrupt you, Chip.
No.
You notice I put a comment in my thing that's called, I call it get_CRC. And you see in there somewhere it says, it says, yeah, I always reflect the initial, no, that's not there. No, yeah, I always reflect the poly based on the way that CRC nib seems to work. So the other reflection bits, sorry, I overspoke there. They're just for the input bytes and the output bytes. So to your point, I do have to reflect the poly for CRC nib in order to match their results.
Oh, I see what you're saying. Yeah. This CRC stuff is really, it's like just prickly. You know, it's like it was all done in hardware, it looks like. And then you try to do it in software, and it wired up in hardware just fine, but you try to do it in software and you have all these reflection and direction issues and all kinds of things.
Yeah. Anyway, I sent you some code just to think about, and I made a little utility. So in case I need to match up with somebody else.
Yes.
Like I said, for the stuff that I'm doing with John and with the laser tag company, we're always using the Maxim CRC, and I have a plain inline version of that because I don't need all I don't care about all of that other stuff that's going on. So, you know, and it ends up being like 7 lines of code. And then Tony B from the forums added some really helpful feedback, you know, that made things cleaner and faster. So that is the beauty of it, is that, you know, really smart people like Tony and others, you know, say, hey, think about this. And it make a difference. I did some speed testing, and a simple little thing. Like I didn't know that RCZ, whatever, you know, the rotate a value into the carry and Z. Didn't know that existed. And so I will put Jeff on the spot if I can. Is he there?
Jeff, you still around?
Yeah, I'm here, just was muted.
Oh, sorry. Are we going to have a P2 manual the way that beautiful P1 manual exists? Because I have 2 copies of that, one on my desk and one that I carry around when I go out and I know I'm going to be standing online for something. I usually have a P1 manual in my hand. I know. I'm really, it's ridiculous.
I need to sign that thing for you.
Yes, you do. Yeah. Or I'll probably have to buy another copy. It's, you know, it's getting a little dog-eared, but you know, it's such a nice manual. And I know that the P2 version is going to be substantially bigger, but maybe it's my age or just old-fashioned or both, but I really like having a physical book in my hand.
Yeah, somebody else was just asking the same question of me the other day. I don't remember who it was at the moment, but he felt the same, that he actually loves using both, bouncing back and forth between the online and the printed manual. I don't know that.
Go ahead.
Oh, I don't know that we ever made like an official decision on it, other than at the very beginning, we decided let's make sure to write the docs with that in mind. Should we decide to let's grab everything and print it? It's a big endeavor to print. Inevitably things are out of date the moment that you send it off. But we'll have to discuss that internally and decide, when's the right time.
For me, the reason I take it out when I know I'm going to be standing online for something is just casual viewing, and then, coming across things that I didn't know before. Like, again, in this case, Tony B was very helpful and said, hey, if you do it this way, it'll run faster. Or, hey, look at this instruction. And with the P2 having so many more instructions, that process of just discovering the new things takes a little time, especially for people like me who are just casual assembly programmers. The pros like Ada and Eric and Evan and other people in the forums, I think it comes to them probably more quickly because they're far more experienced with it. But for me, it's a slow absorption thing, and I like the tactile nature of a book. And showing my age, I won't ask for it on microfiche, though. I promise.
I wonder
I
if
saw
I
some
can,
other people nodding about the book. They like books.
On the subject of showing your age, the CRC discussion, I believe, I'm pretty sure I was around, early enough. That was a technique, not an algorithm, right? It's like referring to a large variety of plants as grass.
Right.
There's many forms of CRC, as you guys, of course, widely discussed, but I don't think there is any standard. There probably are dozens of standards.
Yeah, there are many.
Yeah, and that's what I was trying to do. Was that Tom that was speaking?
Yes, sir.
I went to a table on the internet and grabbed down their test data for all those varieties. It's funny that you use grass as an analogy, because when I first started using Parallax products, I worked for the Toro irrigation division. So I'm a little bit familiar with varieties of turf grass. But yeah, I was just trying to do a matchup and see how things are going. It was a cold day in Los Angeles, and I didn't want to go out. So I sat in front of my computer and experimented.
Good times.
I wonder if you guys can hear me on this analog microphone.
Yes.
Yes.
All right. Hello again. Can I ask a quick follow-up question, Chip, about your changes to Pnut again? So as I was merging that into Pnut, it kind of dawned on me that maybe instead of doing this this additional gamma correction changes, at least in Pnut, that I might actually use this direct bitmap class that I already have as a placeholder and just redo everything as 4-byte pixels. So all the debug window drawing would just use 4-byte pixels, and the alpha blending would be done in hardware by the graphics card, and gamma correction would be controlled by the compositor, which allows you to adjust for that kind of thing. And
so the gamma correction would have to be, if you want GPU to do it, you have to set the texture type to an sRGB texture type, and then it will make it happen. This has nothing to do with the compositor itself. It has to do with only with how you draw it.
But what I wanted to ask Chip was whether any of that would really sacrifice anything to remove that, the 24-bit per pixel and the computations that are currently done in the Pascal code. Just remove that in favor of passing, the transparency value as 4-byte pixels to the hardware and letting the drawing hardware do its thing. Would we lose anything?
Well, okay. Maybe you'd lose the shape of like the radius boxes. But I know one thing that you would lose is the pixel registration is down to like 1/256th of a screen pixel. So this enables things like scope displays to draw traces that are fractional pixel in position. So it looks really smooth on the screen. It doesn't look all blocky. So you'd lose that. And it could run faster. I stuck with the 3 bytes per pixel because going to 4, you have a lot of these windows open that are large. It gets really big in memory pretty quick. It's like, many tens of megabytes can be allocated just to hold those screens.
Mm-hmm.
But on a big machine, it doesn't really matter these days, I suppose.
Okay, so the trade-off was basically for the smoothness of the plots, particularly on where it's something like a scope display where you really want to see the sine wave looking
exactly
like a sine wave.
Yeah. Yeah, it gets around, it makes things look way less pixelated. But you know, I'm sure a graphic card can address that in some fashion. I just don't know. I mean, if I had known enough, maybe I just would have used OpenGL from the start or something, but I didn't know that. So I went through and kind of worked that out myself. That was the
I mean,
hardest code.
drawing a graph with OpenGL is kind of funky because lines are kind of weird and funky.
Yeah, where they pick up and where they end, and
No, the pick up and end is not the thing, but like the thickness and smoothness of them is, and like having them follow like a curve or something like that. It's kind of
Well,
funky.
the trouble, what I'm saying though, is where you pick up and end. Like, let's say you have a multi-segmented line that's drawing a curve. There is a problem that, you know, when you draw one line segment and you go to draw the next, it would take a lot more code to figure out, like, well, what was the deposition from the last endpoint that we're going to be adding to now, right? So what
Well,
we
the
did is we
positions
tend to
are
get,
all floating points, so you know.
well, we get like slight bright spots where lines connect because we're kind of double dosing the light values.
That shouldn't really happen because there's like something like draw rules. So like if you're drawing transparent triangles, you don't get bright parts at the edges of them, but because the pixels don't draw over the same thing twice. At least that's the theory. Sometimes it still happens, and sometimes you get like gaps between solid polygons where you can just see into the void. It's very not strange.
Yeah, I wonder
like
if the
that.
gamma correction that I added would maybe help that a little bit. It might have. Anyway, yeah, I mean, a totally ironed out hardware solution would probably not have those issues.
I guess I'm still a little stuck. Are you actually doing something besides adjusting the actual color rendering of an actual physical pixel? And aren't you doing that just using the alpha blending and gamma correction method?
Yeah. No, we're just modifying these 3-byte pixel values, which could have been 4-byte values, but I used 3 just to save memory. But
okay.
I think implicitly, Chip's method is outputting subsampled versions, right? Like, so to do it in hardware, you'd have to generate a higher resolution image to get the same results.
Probably
and then let the hardware scale it down.
I've heard that. I've heard, yes, people have said that.
Yeah.
Okay. Okay. Well, that gives me something to go on so I can investigate. And I need to look a little closer at the code that's there too. So thank you for
that line drawing and that shape drawing stuff I put in there. That was the hardest code I've ever written in my life. I mean, that like really just about broke my brain.
Okay, then in that case, I definitely don't want to disturb it.
I mean, the graphics, you might have facilities that just handle that. Like, let's say you have some facility and some rendering thing in some GL or a graphics card does it, where you give it a series of points and it will draw like nice lines that aren't overloaded at the pickup and, you know, drop off and pickup point at the segments. Yeah. But it'll do like nice curves. Maybe it can even do Bezier and hardware, and so it can get around those limitations.
Yeah. Yeah.
The hardware doesn't do anything like that. It can only draw straight lines sometimes.
So you have to do it in higher resolution and then have
the other option is to compute the bounding box of what you're trying to draw, and then sort of write it as a pixel shader, which also works, but like wastes significant amounts of computation power.
Yeah.
But that's often how it's done because it's cheap.
I see. Terry asked, go ahead. Go ahead.
Or you do like just pre-generate the geometry for like a Bezier curve to some sort of precision and then draw that. That's the other thing that they do. And that's the thing.
I see. Terry asked about the fonts, the tiny font stuff. You there, Terry?
Yeah. I was going to try to spend some time and utilize those fonts. And the post that I saw in the forum, apparently you have to build the files that contain the fonts.
Yes, that small basic program will grab those BMP files and then kind of work through them and then output the actual binary fonts.
Okay. Yeah, I just ran into some challenge. I don't know anything about that basic, and I downloaded it, installed it, and I couldn't quite get it to work. And I know that it's my own failing. I just didn't have the time to spend to figure out how to actually make it execute the program to spit out the files, the resulting files.
Yeah, all you do is you run it. You know, that thing's always kind of tricky. Tom was here when we loaded the latest version off SourceForge and installed it and put it into the crank bat file that we use for compiling the Pnut application. But yeah, that thing is tricky. It's like I've never like been fully confident about how its paths work and how you got to call it up, and it seems to be sensitive to what directory you launch it from. And so there's all these little touchy things about it that,
I mean, most things are sensitive to the working directory. Are you talking about something?
yeah,
something
that kind of thing. Yes.
Yeah, it works like Unix tools work, but unlike
I mean, if
some
you
Windows
call it
tools
from
work.
like a weird working directory, of course, it's going to try to do things in your working directory. I don't think that's very controversial.
Okay,
It's not controversial, but it's definitely not the way Chip tends to think about things. There's a lot of hard-coded paths in various parts of the development stuff.
Yeah, I just didn't know if anyone had the resulting files laying around. If
I
they did.
I just made them. What I'll do is I'll go to that. I have a little thing here called tinyfontbinaries.zip. I will post this in that tiny font thread on the forum right now.
Oh, perfect.
There's
Thank you.
font 0 through font 7. Super tiny fonts. Here we go. Okay, so here are the binary fonts. All right, so you should see them in just a second.
Thank you.
Another font related question, Chip.
Yeah.
You had done 2 levels of non-full-on pixels at one time. And I think the files you actually posted were only 1 level.
Oh yeah, well, some of the, like the 5x7 was, I only used 1 dither level. I could have used 2. For the 2 dither levels, or like the 2 mid levels were like important for the 3x4, 3x5 fonts. But for the 5x7, I would just put 2 dither pixels at like a 45-degree angle to achieve the effect. And so that's why. Yeah, so that's I'm
so what I saw was actually correct then with
yeah.
Okay, good.
Yeah, I mean, what I'd have to do is redesign those fonts for reduction, like I did the big, you know, the 7x10, 7x11 fonts, I think they were. And so I designed those at 21x33, and then I have them being reduced. And oh, someone's showing something.
What's Brian doing?
Now that probably looks better on whoever's screen that is than it does on our screens.
That was my Linux screen that I was sharing.
Okay. Yeah, so what we saw here, it didn't look, I think that for compression for the Zoom meeting, they, you know, they don't keep it as rich as it probably, does it look pretty good on your screen? Because here
it looks pretty smooth. Like you
I do think they keep all the color. I think they just like, actually, I'm not sure what sort of compression they use for the screens. I think the main thing is that it's just really low frame rate.
Yeah, and they probably go to a palette of like 256 colors or something.
No, they don't. They certainly don't do that, because that takes a lot of time to calculate and isn't actually very good compared to just doing literally anything else, like making it into a JPEG or something.
Oh, okay. I'm thinking like in the year 2000, probably.
They probably didn't even do that back then unless what you were targeting had a 256 color specific mode. But I think I've gone over. No, I don't think I've talked about it. Finding a color palette for a picture is actually a very difficult problem if you want to do it good, like better than bad. Like doing it badly is easy. Like you could just use a fixed palette for everything. But doing it right is very difficult, and well, doing it perfectly is actually impossible.
Yeah.
Because it's a NP complete problem. And that's just for minimizing the mathematical error. That's not even taking into account the fact that the eye is more sensitive to some things than other things. It's actually a very complicated topic. This came up with these Cinepack stuff, which I still haven't finished because I got mad at the shitty Windows C++ tools, and I don't know, it's postponed indefinitely. But that's basically the same thing, except you do it on 2x2 pixel blocks and build a palette of those, which is basically the same thing. From the code wise, it's just more dimension.
I was thinking just now, you know how we put X byte into the chip so it can pick up a byte and then use it to look up some skip pattern and a jump address and jump there? I could have totally done that instead of using, like when I go to the FIFO, instead of grabbing a byte, I could have done an RF var, right? And picked up some variable sized word and then done the same process with that. And that would have that could have like totally sped things up. It would have changed, you know, the implementation and how we wrote the code a little bit, but it could have gotten around some issues. I could have put like beyond the 8 bits or whatever, I could have put that into PB or something, and it could have saved a lot of steps.
Eric would have found that very funny, because that's basically what part of what he's doing with his funny bytecode thing is basically generating a bunch of bytecodes, and the more bytecodes you can generate, like instead of having a fixed set, he first finds out all the ones that are needed, and then he finds all the combinations of bytecodes that go together. Like if you often push the number 2 and then read from that byte from that, if you read the byte address 2 a lot, it will notice that that is a common bytecode combination, and will then make that into one bytecode. It's kind of funky, and the problem is that it's limited to a certain number of codes. And for the ones where the implementation has to spill into the hub, it actually has to do a weird thing to sort of that's very slow and jumps around a bit.
I see. Is this Vulkan graphics thing, is this something new? Jacob Jones.
Well, not especially new, but it's
new is something else.
Pain, yeah, that's a different thing. Yeah,
that's the thing. It's technically the new thing, but it's like check out like Vulkan triangle example. You will never want to use it because the example that draws like a single triangle to the screen is like 1,000 lines of code or something. It's actually mental. Let's see.
Well, it's a graphics card level interface, isn't it?
Yeah, it's
Vulkan?
very low level graphics.
Right, and it's basically an open source project to unify, everybody's graphics cards under one open source driver with pluggable backends and that sort of thing. It's pretty cool. Yeah, but it's not a you definitely don't want to write, user display stuff in Vulkan. You want to use some drawing, library.
I mean, it's useful if you want to, if you kind of know what you're doing, it's obviously useful. But if you just want to write like a simple thing, it's completely overkill and makes you mad.
Oh, for sure. It's totally the wrong abstraction level for productivity.
I mean, what they do is it kind of makes sense, because with OpenGL you have a lot of stuff that is sort of implied, and if you don't change it, it just is like that. So with the Vulkan you have to set everything up explicitly. There's no defaults that you can set, and that's why that's the kind of part of the good thing is that normally with the OpenGL, sometimes the graphics drivers, the different ones do different things that it doesn't work anymore. If you've ever used an old ATI card, you can probably attest to that. I have seen things. It is very, I've seen things that should not have been seen.
Well,
Just
I
like
think we'll
text
move
buffers
us
rendering
on.
in the sky.
Everybody ready to talk about something new?
Sure.
I see a bunch of heads nodding up and down. Okay, well, on the way to the Raspberry Pi stuff, we'll just make a little pit stop at this screen image. Okay, that's the back side of a new board. That's not what I wanted. How about the front side of it?
That looks awfully live. What's going on?
All right, not right. Getting closer. Got 50-50 chance. Okay. Now you're looking at the P2 Edge breakout board. Has anybody seen this?
I saw mock-ups. This is exciting.
Okay, I think
Looks like a winner.
this. So this board was created out of necessity for a customer who's using the Edge in a production project, needed everything tightly placed on a board. So reading the documentation, I'll give you a few ideas of what this is about. Accepts the P2 Edge module, includes a supply voltage, DC jack, power headers, prop plug connector, reset button. All 64 of the P2 Edge Smart I/O pins are available on the pin header sockets, compatible with both single and dual header P2 accessories. So that's the difference between this board and the mini breakout board, which is part number 64019, that does not have access to all of the pins. And additionally, the last header includes programming and memory pins 58 to 63 and the reset signal for wireless programming when using the WX adapter, which is our part number 64007, with the WX ESP8266 SIP module, our part number 32420S for wireless programming. So these are made entirely as through-hole on our selective solder machine, and the BOM cost is cheap, and it is part of our effort to make a really lower cost getting started point for people. So do you like
Cheap
this?
and plentiful.
Yeah.
I mean, it's for most people, it's probably better than the big breadboard one, because that includes a breadboard that most people just have laying around anyways. I guess the thing that it doesn't do is, the nice thing about the breadboard one is you can plug into the breadboard while also having the same thing on an accessory, but that's like incredibly obscure. So I guess this is a very good board.
I see. Is the intention to plug 5 volts into it? Or can you use like 5 to 16 or so?
Let's look at the documentation.
Is Michael Mulholland still here?
Uh, 5 volts.
Okay.
I'm here.
I think depending on your edge, you can probably use the higher voltage one. But if you have like the USB accessory connected, it will explode everything connected to that. I think that's the limitation there.
So the idea is that you get like probably a USB wall supply, but have it go from a USB-A to a like coaxial power connector. Is that it?
Yeah, what Ada said was just spot on, really. The
No.
you
The
could-
right way is to go to Parallax and order it. You have in your shop a very nice wallboard with USB and connected to that connector you need. It's already there in the shop. Ken has to find the number, but I got 2 of them. Pretty nice 5 volt directly wallboard, but basically it's a USB connector with on the other side and the plug we need.
Oh, okay, yeah, a USB-A to DC jack cable. Okay.
Right. It's already in there, and it's not even expensive.
Yeah, a couple bucks. Yeah, so this, we hope this is like $10 to $15. Cheap.
Maybe I got some with some of your mixed packages here. Works nice, and it's what I like on it. That's not that short. I don't like those short power wires. It's
Hey, is there a place to be, so you can put some like rubber pads underneath it?
Some little feet.
Yeah, so to keep
Yeah,
it
it
off the
ships with
table.
the rubber feet.
They're on the bomb.
Oh, it ships with them. Okay. Oh, they probably
Yeah.
go under those tool holes, huh?
Yeah, you can put them where you like, but I think we put rings around the 4 holes as that was convenient.
Okay, yeah.
One question I have about it, do the pin pairs allow you to, if you had designed a board that would use 2 of the 12 pin connectors there, is the spacing the same as it is on the Johnny Mac board and the eval boards?
Yeah, all the edge headers are spaced to accept dual boards. So you could put 3 dual boards on this. I mean, you could put 4, but of course one of them's the programming header, so
right.
Probably
How
not
many
so
dual
useful.
boards are there even?
Okay, perfect. I really like this board.
I think the only dual boards are like the memory expansions. Are there, or is the one that eludes me?
Well, Steve Morocco will mention a board that.
The motor one. That's also 2.
Well, the motor one, but also the LED Matrix Hub 75 card.
The
Which
LED
oddly has
Matrix
my
one's also
company
done.
logo on it. Yeah.
I guess the memory expansions are the only one I have.
See.
Yeah, I want to build one for the W6100 so that we can just add Ethernet on, just snap it on.
Yeah, please.
Yeah, I'm glad you asked that question, Terry, because I have DipTrace open right now. I'm working on a dual connector board, much simpler than your Ethernet board, but I need it nonetheless.
So, and then I could just answer the question briefly about the power supply if you wanted. You can plug in any power supply that's good for the edge module voltage. So the latest edge module will take 15, 16 volts. But as Ada pointed out, if you're running 5-volt accessories, that's probably a bad idea. But with the power header thing there, you could take off the shunt jumpers and hooking your own 5-volt source to run the accessory headers.
Yeah.
You could also use those shunt jumpers as switches to be able to sort of switch on or off. You could remove the jumper from the 5-volt header and just park it over on the ground headers or something. And that way you don't have 5 volts, or, if you're using 16 volts or whatever, you don't have that going out to the 5-volt headers. You can use them as switches. You could use those to inject your own voltages there. And actually, if you're using these in a project box later, perhaps you don't have space for the barrel jack connector to go in the end. So that could be a good use case, I think, to remove the shunts and to possibly hook your own power source straight into those headers there. So it's quite flexible like that.
Yeah, but no reset, though.
No, the
reset down the bottom, yeah, just above the plug head.
Okay, cool.
The photo angle is a bit curious because it looks like half the, you can't see some of the stuff, but it is all there.
Michael, your VSS for the programming connector, where's that coming from?
For the sorry, I didn't quite understand that.
For the 4-pin programming header.
Yeah.
So if you've got a higher powered something coming in the jack, what's that doing down there?
Well, that's just the common ground.
Oh, the VSS is ground. I'm sorry. I was thinking.
Oh, I
about-
see what you were thinking. Yeah.
Yes.
Okay.
Sorry.
Yeah, no, you're safe. You're safe.
Thank you.
Okay.
Yeah,
Well, how
and
about
so
if we
this
move
board
on?
is going to be the, it's probably going to be the ideal board for the P2EC now, because you've got all the breakouts, and then the prior board, the 64019 with the 4 headers is probably going to remain the ideal choice for people using the RAM version of the P2 Edge, because that only has half the headers broken out anyway. So why would you want, the larger board with all those wasted headers? So yeah, hopefully this.
I actually do use the base 32 pin header on my P2 Edge, because like the bottom 4 pins are all right. That's enough for VGA.
Yeah. Yeah, but I asked Michael, and he.
But all the other ones on that side of the breakout are completely useless.
Not really, because there are you can solder on the bottom. There are circled the pins you still can use. Michael told me somewhere in the forum.
Yeah, we did label the
yeah,
bottom
missing
pads so you can see the spare ones and solder them out to the proto. Yeah.
To solder them to the proto thing, yeah.
And Bob Sweeney just asked about availability. They're going through manufacturing now, so at some point during next week, I'm sure they'll be in the store.
Nice.
Great. So we're really close then.
Yeah.
Michael, you know more about what's going on at Parallax than I do right now.
And Michael, so much for doing this. This is an excellent board.
Yeah, that's good. That's going to be nice.
It was a really quick effort. Okay, so it was a pit stop on the way to this other topic, which is the Raspberry Pi. So we'll get back in the car now and let's talk about the Raspberry Pi. So some of the talking points I had in mind about it. First, I should tell you, these things are just crazy popular. We all know it, but we are an authorized reseller of these. And whenever we get them in stock, and we just placed a massive order for well over $100,000 of more of them. I'm still trying to figure out our fit with this product, to be honest. It's very popular. We don't make anything selling them. We have to be careful, even at the cost of a piece of paper that runs out of our printer, to make these worthwhile and use USPS boxes. Because there's, yeah, that's right, Jacob, we're going to get there. He's ahead. So they're fascinating to me because we love to sell things that are very popular and like to go sometimes where the popular kids hang out. And that's what I'm thinking about with the P2. Because it's important for business. So in regards to the Propeller 2 and the Raspberry Pi, what are the uses that we have of it right now? I think there are 3 of them. And then I just want to have you guys talk about what the others might be. But the big 3 uses are the IoT gateway, which is our email send and receive that Stephen Morocco's put together. They're quick bites for it. And then there is remote desktop programming access of the P2. And then recently we got Brian's Linux build. I think, so I might be going into 3 or 4 things here, but FlexProp, I believe, is running on it. And as a companion, as a real-time IO super capable embedded controller for the Raspberry Pi. And then I also wonder, why couldn't the P2 be used as Chip's P2 standalone development system? And so Chip doesn't actually have one of these, but I'm sending him one so he can really get a close look at it. So I just want to throw those talking points out there and see what everybody has to say that we need to know about the Raspberry Pi and the P2 and what we're missing and what we think the priorities might be. Anybody?
I think that's a great idea, Ken, to use the Raspberry Pi as a development system for P2, because it does give you a known quantity. Like people, at least in theory, you could set it up so everyone could use it from their PC using a browser or something like that. And the Raspberry Pi would do the heavy lifting of compiling stuff and downloading it.
So what's missing right now when you do that? You're using FlexProp on a Pi, is that right?
I don't have a Pi myself, but in theory, you could certainly use Pi. I think Steven's ported Visual Studio.
Correct. Visual Studio works there, and I do use FlexProp, and I remotely access the Pi from Visual Studio on my desktop, Windows or Mac, and it remotes and runs the Visual Studio editor stuff on the Pi. It also runs FlexProp on the Pi, so I can immediately to a USB attached on the P2 USB attached to the Pi, immediately compile and download code. So that's all working.
I believe you can just hook up your keyboard and display right to your Raspberry Pi.
Yes, you can do that as well. But I have so many.
Skip the other machine.
I have 23 Raspberry Pis in my house, and so.
Right.
I mean,
I'm just thinking for as a complete package for others to sell, bundle it already that way, keyboard, display, turn it on, and you're coding.
That's certainly one way to do it. Another way, as I say, might be to try to develop something to make the Pi plus P2 just be a node on your network that you can access from anywhere, from your phone or from a PC browser, and do your P2 development.
That's essentially what I had done in the past with the P1. I developed a board with a P1 and a GPIO connector that hooks up to a Raspberry Pi 0 or 02. And basically that becomes the remote development system, and it completely controls the Propeller one in terms of resetting it, downloading code to it, restarting it, responding to button pushes that are sensed by the Pi, all kinds of stuff. And it was actually quite easy and enjoyable to make, and works quite well. So I don't know that I'll do the same thing with the P2, because with my P2 project, the P2 Edge module kind of replaces the Pi and does everything and more. But on the P1 version that I have, it's a fantastic coupling of the two. It's so flexible and so easy to develop for, because my project is sitting on the other side of the room, connected to an Ethernet port. I have wired LAN in my house. It could just as easily be wireless, but I don't like the latency of the wireless. But I do everything from my desktop, AMD Threadripper Linux computer. I cross compile code and I push it to the Raspberry Pi, which is connected to the P1. And I'm cross compiling both the Propeller code and the Rust application that runs on the Raspberry Pi. And it just makes for a really nice development environment. The two couldn't be better together. It's like peanut butter and jelly.
So what's missing? Anything in that way from the development environment need?
I think making it user friendly.
Documenting it.
Yeah, having it not be a one-off kind of too proprietary.
I think the main point, Ken, is you just have to sell it as a bundle. You don't sell them without a P2.
Mm-hmm.
You just sell those Raspberries with an Edge and a Breakout. That's the point. You have not sell them alone.
That's a different question, I think. I mean, because people sometimes just want a Pi, but if you do want a P2, a Pi would be a great development system for it. Again, if we had the software, like if we had it all set up nicely so that the user can just plug the Raspberry Pi into the network and then program their P2. You could imagine Prop Tool, if Prop Tool was running on the Raspberry Pi with some kind of remote.
You can put Windows on a Raspberry Pi.
So one of the barriers for me with Pnut, getting it over to an ARM system, which includes the latest Mac OS systems too, is that the i386 compiler that sits at the core, it's Intel code. It's not ARM. It's not PASM. It's just Intel code. And barring some kind of a built-in emulator that would allow that 32-bit Intel code to run on the Raspberry Pi emulated, that maybe that's the easiest path to get there. But
I mean, you could just run it under QEMU, right? I think that's just a thing that it can do with like
Well,
install
again,
translation and everything.
But to make this all user friendly, we'd have to package everything together. I mean, another alternative obviously is FlexProp, because that does run on a Pi now.
Yeah, that
But
just runs on
whatever
everything. because
solution
it's
we
good.
come up with should be what I'm thinking that someone would want to sell, and maybe it would be Parallax, is a bundle with a Pi, an SD card with the operating system and all the tools installed, and their P2. So
I feel like having the operating system pre-set up is a road to madness, but also having people set it up themselves is a road to madness. That's kind of a problem because if you give them a prepackaged OS, it's going to be 5 years out of date before you spin around one.
The whole point of this, though, is that it's a plug and play. Like, we don't care how out of date it is. It's
yes, we do care, because as soon as they do something else with it, like try to install something on it, it will break because some idiot took down the package repository.
Well, but then they don't do that, or they install their own OS. If they're at the point, if they're sophisticated enough to want to install new packages on the Pi, then they can install a new OS. What I'm thinking of is for something like an education, if you want to sell a school 200 of these stations, they just plug them in and they work out of the box. They don't have to do any configuration. They don't update their software. They've got a development
That's probably works. If you don't expect it to do anything connected to the network, really, then of course it will work.
Yeah, but that update network thing is exactly why Chip wants to do the development on the P2 itself, because there we could basically set up some system, let's say with a P2H with RAM.
I mean, then you just have your own update hell.
But this is the same thing, Michael. It's just using the Raspberry Pi instead of the P2. So,
yeah, but then you have the Raspberry Pi and the whole Linux and the whole packet manager and all that bullshit instead of just one SD card.
You don't have a package manager. No, that's what I'm saying. You have the SD card. It's all pre-installed. The Raspberry Pi is just a black box for this purpose.
And then kind of an SH script with update, and it pulls everything from Git. Oh.
Well, no, you probably don't. Well, I mean, you could provide some way to update, but it would be.
I mean, you could make something like the immutable file system like they have on the Steam Deck. That shit updates every time. Whereas if you've ever upgraded a Linux distribution, just try to install updates on something that's rolling release, you will know that it explodes regardless of how much you've actually done to the machine.
Hey, gentlemen, we do have a nice compatibility package into the Parallax system. And that's the Raspberry Pi. In middle schools and junior high, they're running Scratch. So Scratch is their compiler. Blockly is very compatible as far as their talent, their learning, next step into an engineering level Scratch. And I'm using that transition for the Pi onto, in case of Blockly, I'm using the Flip and the QuickStart. And with small boards that I've produced, they're plug and play. I don't troubleshoot wiring, I just teach code. So that's the nice package that already exists.
Yeah, and that's Mike's a community college teacher, and so he's using them not together but progressively. Am I right, Mike? Like you use the Flip on a computer when you get there.
Yes, and like I say, on a computer, I have a bunch of little laptops, but I have used the Pi as my programming environment too. Like I say, doing the Scratch portion with the same boards, and then whether it's a traffic light we're sequencing or a little game board, a Simon board, something like that, we move it right over to the Flip from the Pi. So they've already built this code once, now they're just doing it in another environment with a little more power.
Cool.
Yeah. Yeah, and Michael, to your point, yeah, we bundle these things. That's how we can make a little bit of profit on them. So we're doing that. So it sounds like from a development tool perspective, the user friendliness is just maybe needs to be documented, and we should share that. if we want to do P2 programming from a Pi.
I mean, it's the same as you're doing it on a
And-
PC because it's just a small PC.
Yeah,
Well,
and
it's
P1.
there's two ways to look at it. There's one way is using the Pi as a PC, and the other way is doing what Chip wants to do, which is providing a built-in development system that's uses the Pi. And
Yeah, then there's Chip's need here for standalone. I do wonder if Blockly Prop can be run on a Pi. I don't.
Oh yeah,
think
I'm sure
it could. Really, our version.
Isn't it a browser thing?
It is.
In
It's
that case,
Chrome,
it works.
any browser, but we install some software on the computer in Chrome.
it's probably one of those cases of it could in principle, but it
Mm-hmm.
probably doesn't.
Maybe
in
somebody
practice yet.
wants to try. Yeah. So
And I'd
that's
be
good to know.
excited if you give me Blockly on the P2.
You would be?
Yeah, sure.
Yeah, that'd be great.
Hey,
Well-
Michael, how would you feel though about like what would be the best way to program Blockly on a P2? Would you want to use like Chromebooks, or would you be up for even self-hosting directly off the P2 if you had to plug a monitor and a mouse into it? Keyboard?
Yeah, I could see a monitor and mouse on another daughter card or expansion card.
Would that be practical, do you think? Or is it, because I've had this long-term drive to put everything onto the P2 itself, right? And just kind of get away from all OSs, which is not a popular idea. And it seems a lot of people to shake their head, but I have this drive to do this. But you know, you'd have to have monitors, keyboards, and mice to plug in. And a lot of people they just want to carry around maybe their Chromebook or their laptop or their tablet. They don't want to have anything extra, which I totally understand, but
Just build a P2 laptop. They make like 800 by 480 funny screens that you can just drive directly with some bits into the thing.
But why use a P2 for why do the heavy lifting on a P2 when you can do it on the PC? Like have the P2 serve up web pages that have the compiler and everything in in WebAssembly or something.
Yeah, no, that's a neat idea. But my thinking is just to get away from this entire, you know, it's just ever convolving complexity. I mean, I can't even give any of you an EEX file right now, right? Because your Windows is going to say, hey, I don't know this application. It's probably dangerous. You know,
I don't know. Mine doesn't.
Yeah.
Well,
those of us behind strong firewalls.
Right.
I mean, couldn't the P2 just be like a little server that you push your source code to and it compiles it and starts executing it?
Yeah, no, it could do that. It could do that.
Right,
I mean,
so
that
your
would be
client
nice.
is whatever machine you run your editor or browser or Blockly prop on, that's your client. And that client just knows how to talk over the network to push the source code, you know, your spin2 or whatever source code over. And then the P2 as a server, just a network server that knows how to quickly compile what's changed and restart the application, and you see your changes rapidly, kind of like we've experimented with.
I'd carry that a little bit further than that, Brian. I'd flip it and say the P2 can hold the compiler in its flash and serve it up as a web page, but the actual compilation can happen on the PC that has tons of memory and it's much faster. And similarly, the editor and everything could run in the web browser on the PC. The files can be saved on the P2, so you keep them. But
sure, but I think part of the dependency issue that Chip is trying to work around is that all the tooling, as the tooling migrates its way across all the different devices.
No, I'm sorry, I wasn't clear. The tooling is
on
on the P2, but it's in the form of WebAssembly. So it runs on the PC, but it's served up from the P2. It never changes.
Okay, I got you. That's clever. Yeah, I see that.
And normally these web browser things are very hesitant to break. Like that's one of the few things where they put effort into not breaking things all the time is web browsers, because people hate it when they go to a website and it doesn't work.
There's something on that, yeah.
Yeah, I mean,
Also, they
JavaScript is the
basically
runtime that
cannot
covers
make
it.
like they basically cannot make a new browser anymore because it's gotten to the complexity where you can only change the existing browsers. If you try to write a new one from scratch, your brain will explode.
Yeah, I mean, that's the beauty of JavaScript is that's the runtime that everybody has. It's everywhere in the browsers.
Yeah, I mean, we could serve up Java Java code, right, to a web page and have it effectively do compilation and everything on a host platform.
I did that with Heater a couple of years ago.
That's called WebAssembly. It's basically where it's basically assembly, but for the web. It's very funny.
Yeah.
It's basically some sort of bytecode similar to what Java used to have, but except different because we have to invent a new one. I don't know. And you can actually compile straight C to that. It's very, and probably other things, but you can do C. And it will, you have all the normal things, like you have your memory, you have your bad string handling, you have your, so it's not, so you could make something that runs on a normal PC program, but you can also make it run in the browser now through dark magic.
What I did with Heater was using emscripten, and we just run the source of OpenSpin through emscripten, and that kind of made JavaScript out of it. I haven't tried it with Flex, but basically the process is the same. emscripten basically compiles the C program to JavaScript directly without skipping that it was before WebAssembly existed, more or less, you know.
emscripten, I think, does both WebAssembly and the JavaScript thing. It's basically WebAssembly was invented because compiling to JavaScript kind of sucks.
What I did with Heater was basically the following thing. We used that thing here. Can you see that? I don't know. It's a spinneret. It's a parallax.
Right, yeah.
It's a P1 with a, I think it's a 5200 PS BizNet. A very nice board. I still have a couple of them. I wish somebody would build more of them. And we basically run a web page on the spinneret, had emscripten as compiler in the browser, and an editor Heater built with kind of, I still have an editor 17 or something. You basically could edit in the browser and compile with OpenSpin in the browser, and then put and get the other thing is put, you know. You could put the file back to the web server and run it there. That thing we did a couple of years before Heater disappeared. It was even online. I still have it. I found it lately, and it's on here. And running. But basically, that was development in the browser, more or less, you know. That's not really because what I think, and I'm with Chip there, that development on the P2 directly without the need of having any computer around it.
Yeah, and you know what would be really cool too? What if we made some kind of point-to-point internet network for all these systems, and we could, like, you know, share code, talk about anything. It could kind of be the basis of a community that would.
Yeah, you need definitely some Ethernet connection to do that. Some P2 board with Ethernet connection. Stephen is working on something like that, doesn't you? Stephen, you have that BizNet 6200 thing?
No, that's not me.
That's not you. Somebody has in the forum is working on that.
I have Ethernet working reliably on P2 using the BizNet W6100.
Yeah, and that's cool. That one is better. The spinneret I have here is just 5000. It just has 4 concurrent connections, and that is kind of tight when you do DHCP and other stuff. You basically have just one browser left. You know, kind of. So,
Yeah, I did some sneaky things with mine where if a browser attempts to connect back up with a persistent connection, it bats that connection down, and the browser eventually gives up. And so I did a workaround with that. I'm only running one connection on the web server on mine, and I'm going to play around with doing multiple connections on it. But yeah, that was definitely a problem. I remember whenever I was fooling around with the spinneret, and at the time I didn't quite understand what it was, and coming into it from having to write the driver, it's like, oh, this is what's going on.
Yeah, kind of a spinneret board for the kind of a plug-in for the heaters. That would be nice.
I think your spinneret board for the P2 is a Raspberry Pi.
Yeah, but then you
Indeed.
get that OS problem and all that bullshit.
Which problem?
The OS, you have to be aware of Linux. You have to program it in Linux. You have to.
No, it's not at all true. I set it up, and I'm a total ding dong.
Yeah, you just treat the Raspberry Pi as a spinneret. It's
and 10 years later, you go to your site.
You don't.
Start the same.
You update your. You don't update the Raspberry Pi.
Something in, say, Pump House. 10 years later, it breaks down. You go down there. You have there a Raspberry Pi installed with a 10-year-old Linux because it's installed at location, and you have to fix it. If you have a P2 there, you can.
I mean, you could just swap it for a different Raspberry Pi, but more likely the reason that it fails is that the SD card got exploded by the Pi, and then you're like shit out of luck if you don't remember how you set it up.
Right. Yeah, but basically, we are working here with microcontrollers. It's not that. I mean, what I do are installations, and I never see them again. And maybe in 5 years, or somebody calls me and says, "Hey, Mike, it doesn't work." You know, and if you have the development on that system itself, you could go there with whatever you have in 5 years, cell phone, watch, as long as you can get at least an USB connection or serial, you can work. I mean, that's without Raspberry, without Windows, without Linux, without Mac, without drivers, without all that bullshit, because you have all of it on a P2. P2 Edge should be able to run stuff like that. I mean, sadly, I'm not smart enough to build a compiler. Else I would already have tried to build a compiler on a P2. Spinks is doing that with a P1 and mparks. I have it running now again.
I think
compiles and edits on a P1 without any computer. You can edit, spin 2 files, you can compile them, you can run them. He did that 8 years ago. It's www.spincompiler.com. They find everything. It's still working. You can put it on a P1 and it's running. You need the main problem is you need an FAT16 SD card. So there you have to look, find an SD card with, which you can put FAT16 on. But then it works. You just connect a TV and a PS2 keyboard.
It's interesting to me that in all of these discussions about different shapes, we all see that we still have distribution of updates issues for the tools that are on the P2 or the tools that are on the RPA.
Right.
We have initial configuration issues. We have replacement for failed hardware issues. It's the same no matter where we go. And so to say one environment is significantly different over the other, I'm not entirely sure it is. given that we have the same issues. When you're talking about the P2 as native, you've got a whole bunch of infrastructure that has to be created from the ground up in order to provide that distribution, to upgrade the tools that are on the P2. It has to come from something.
Yeah.
Okay. And so I don't think we can gloss over this as quickly as we are, saying one is more natural than the other. That's my opinion.
One of them would not exclude the other one. I mean, we have all the tools for Windows and Mac now, but we don't have any tools running on the P2. I mean, that's just the missing part. That doesn't mean that you just have to development on but you could. I mean, that's the point on it, you know. But on the other hand, I like that the Raspberry P2 connection also very much.
Yeah, I could see how a Raspberry Pi basically could be an appliance for programming the P2 and having it as an appliance for a complete IDE environment where, okay, here's a Pi with the correct image on it so that all of your students can learn how to program the P2, and it's the same for everybody because it's just an SD card. You duplicate that, you provide it for them, and have it to where you have a P2 hat or something that goes right on it, and you have your pins out of the P2 that are going to control whatever the device is. I think they pair well.
Yes.
Yeah. Mm-hmm.
Kind of a heater board.
If I could, Ken, you've been through the process, and I think a number of us have been, from taking a out-of-the-box Raspberry Pi and getting to the point where you're interacting with the P2. What kind of an effort was that? You're asking Eric and Chip to probably follow those steps with my instructions. How do you characterize that effort? And we also have a quick bite describing all of that, of course.
So there were pieces of it that I had to go to the web and get from your GitHub, and I just copied and pasted them and ran them. Let it update I updated the BIOS, I let it update firmware. It took the whole thing took like an hour. And from there, it just worked, and I could power cycle it and it would restart. The way I configured it. So it was no big deal. And I could have pretty much just focused on P2 code. I didn't know anything about Linux or directory navigation, but the instructions included what we needed to know about it. So I got it from there. Not a big deal. You and I worked through a few of the hiccups as we proved out the documentation while I did that. So I thought it was really impressive when it worked. And I felt like it was more accessible than, say, working with an embedded controller that's doing all the TCP/IP stuff and the stack, where it's a little more off limits and I can't tell if it's connected or tell what's going on with it. Because the Pi, you can see you have an internet connection, and you have a familiar looking setup like a computer to get it on the internet. And I liked that. But it was just hard to imagine for the price and the ease of that, setting that up, that there's a better way to get this on the internet, to get the P2 work on the internet.
One of the interesting things is the Raspberry that we just had to go through recently with the commercial product was that the Pi automatically grabs its time synchronization from the network, two very precise values, and forwarding that to a real-time clock enabled P2 to set up its clock immediately when you first come up. That's going to be an easy, trivial thing to do, and will be part of the gateway software.
I mean, if you have the Pi attached, you don't really need the real-time clock, right?
I'm not exploring that issue. I'm saying we're going to have it on an edge card eventually. So how do you set it up reliably? And that's what I'm talking about.
RTC on an edge card?
That was one of the things that was talked about in the past, yes.
Yes,
Curious.
please.
Well, if you have internet, you don't actually need it as long as your actual clock source is good enough to it and drift too much, because we do have the 64-bit counter. In fact, with the way that the FlexBin library sort of thing is set up, FlexD rather, you can actually set the time and it will just keep it going until the 64-bit counter overflows and at the heat depth of the universe, you know.
Well, that's nice. I didn't know.
I'm using that 64-bit counter as an uptime indicator on my
Yeah,
light controllers.
I didn't use that FlexBit already gives the opportunity that you kind of set the actual date at start, and then you can use it in Flex as a time running from the counter. Already added the difference of the actual date.
Yeah, I don't know how well it would work over time. That's been one of my concerns, because I'm eventually going to add NTP protocol and grab that and basically set an epoch from boot time versus what is actually there. And I wonder how well the P2 keeps time like that with that 64-bit counter. I assume it's good enough for what I'm using it for, but
probably good. Like it's pretty accurate in terms of the frequencies that it outputs if you take care to calibrate it against the actual clock frequency rather than theoretical clock frequency.
I think over several months, I'm not sure how good that is.
Something like 7.
I don't think that what's the sort of errors for the resonators, not resonators, the weird bizarre oscillators that the edge uses versus say normal clock crystal? That's a good question.
5 seconds per year is what Chip calculated.
Well, that's for a clock crystal or for the weird oscillator.
Counter of the P2.
For the weird oscillator, I think it's 15 seconds per year or something. It's half of a ppm, 500 parts per billion.
I think that's pretty good compared to most like cheap 32 kilohertz crystal.
Yeah, definitely. Yeah, but having a Pi as kind of a peripheral for P2 programs, you could access network, you could access probably printers.
Yes, it's got full large display, everything.
Yeah. I mean, you could basically, that would be a bash shell as an object in P2, like a serial. The command shell as a serial object. So from the P2, you can send commands and receive the response. Yeah.
I mean, they can just do that. You can, I think there's a setting in some bizarre file that you can enable on a Raspberry Pi, and it will give you a login shell over the serial port. You can probably disable the login, and then you can just run whatever into that.
I tried that out, but what was not the Raspberry Pi, it was another microcontroller Linux thing, and you could put the shell on the serial port, and then I could kind of talk to it from the P1 at that time, and getting the answer back. So, and then you have access file system, you have access internet, you have access to printers probably.
Michael, you're explaining why we have the IoT gateway.
Printers. The funny thing is the printers almost always work. Just it's a weird Linux thing. If you have anything else, it sort of has weird issues, but if you have a printer, it always works.
Oh, okay. I don't do Linux. I mean,
it usually just. But if you want to scan something, oh no, it will have weird issues and take forever to do it.
IoT gateway, yeah.
Mm-hmm.
Yeah,
it's about time. Go give it a look.
Yeah, building everything needed to do a full IoT gateway and all that. That's a lot, and I think the Pi is a good way to do that. I mean, if there are specific things you want to accomplish, networking wise, you don't necessarily have to have it. But if you want to do things such as complex encryption, like I'll give an example of one of the things that I've ran into that it's beyond me. I can't do with the networking that I have, and that is SSL. Yeah. So with the Pi acting as IoT gateway and serving up stuff, you can do SSL.
No, you still can't do it because you can't get a certificate for like a local IP address. So unless you're using it to host a public thing, it's pointless to have SSL.
Well, that's if you want to, if you care about name validation, but if you just want to ensure that your traffic's not being sniffed.
No, you can't. You cannot just, it will always flag it if it doesn't have a valid certificate. The only way around that is to manually install one.
Yeah, you manually install one and you accept your self-signed certificate and you move on. But, I mean, there are no libraries built. Like I went around looking to see, what SSL libraries are available. There are small SSL libraries. They're all built in C, and they're all built for specific processors because they take advantage of, specific, things available, things available on those optimizations for those processors. Yeah. I mean, can it be done? Yeah, absolutely. P2 can absolutely do it. Is there something there where you can just go take something off the shelf and make it work now? No, except for.
Yeah, well, if you have on a local network, I don't think it's that important to have it not get sniffed unless it's a big network, right?
Okay, so I'll give you an example of where the problem affected me directly. That is, I am pulling down updates for these controllers I have all over the place via the internet. And I had to set up and configure the place where I'm pulling those from, which is via, it's blob storage, it's via a REST interface where you just do the request and it sends it to you. I couldn't put it on my website because my host would not allow me to have just standard HTTP because of the way they have it logged down. So I had to open up an account with Microsoft, create blob storage, and then tell it, okay, I don't want this encryption there. But it's getting harder and harder to get around that kind of thing if you don't control every aspect of the infrastructure that you're hosting.
I don't think every aspect of the infrastructure is a bit too much. Like if you have some shitty VPS, you can probably set that up to serve raw HTTP. But I get the point. Yeah, a lot of hosts don't just redirect straight to HTTPS because old computers don't exist. I don't know.
It's one of those things where it's like 20 years ago on to ISP, I know every aspect of Apache and networking and the entire layer of that. I did the business that they're running, and whenever I call up their support people, they don't even understand what I'm trying to ask for. There's no there's no way to even get them to understand, hey, I would really like to have this directory that doesn't have HTTPS on it. I
don't know, the Indian tech support guy that's paid like 5 cents per year doesn't know that and probably thinks you're like crazy or something.
Yeah.
It
has
directly to the guy who actually knows, who may or may not exist.
Yeah. So I mean, I literally spent hours trying to get around that problem before I'm like, okay, screw it. I will go set up, blob storage, and I know that I can turn it off there. However, if I had something like the Pi, if I was using something like the Pi, all of those problems go away because all of those levels of standardized encryption and all of those things are.
Well, if you don't update it for long enough, the server will eventually stop supporting whatever encryption it has.
That's true. That's true. You've got a lifetime of about realistically 5 years before everything stops working.
Yeah, that's how it goes.
I always have it's always funny using the web browser on the Wii from like 2006 that was never updated beyond that. It mostly works, but you have to click past 20 certificate expiry errors every time you go to any page. It's very funny. And also half the pages don't work because it's 2006 browser, but and like people don't care about the websites working in these old browsers that are never going to get updated. It's kind of obnoxious because it's not that hard. You just have to like not do it stupidly. Like just most of the time it breaks because it uses some sort of stupid JavaScript thing that it doesn't need to begin with. It's very strange. I have messed around with the old Internet Explorer emulation. It's actually very possible to make a website that works in like IE5 from forever ago. By works, I mean it's readable without like completely fucking up, not looking good. Looking good reads like IE11 at least.
Yeah, you can basically just use HTML in the original form and you have no problems everywhere, but no JavaScript, no CSS, no if you get
actually you can just use CSS works reasonably well. It's very progressive enhancement is what the is the funny term for this. Where you can have a thing that gets used if you use like an advanced thing. It will notice, oh, you have to put like transparency on that thing. It will look cooler, but you can make it so that if it doesn't have that, it doesn't freak out.
Yeah.
Well, anyway, my takeaway from listening is that we need to update the IoT gateway documentation, which Stephen is aware of. And I haven't done that yet. And then the remote desktop programming capability. So using our tools on the Pi to program a P2. And then outstanding item in my mind is to maybe get Chip convinced that it could be a standalone system.
No, I'm against
Not going to
that.
happen, I know.
No, I'm against that because Chip's idea is good. Not as the only development system, but there is in my opinion, the Raspberry Pi combination perfect. But as an alternative way to do it, I'm really interested in that one. I'm porting that Sphinx thing, then I can.
No, you're really interested in it.
I can.
Let me ask you a question. How many P2s have you bought for your commercial applications?
Me? No, I don't have any P2s.
Okay. Who else is really interested in standalone development system and is using
Currently I
P2
have
in
5.
products?
I have five P2 products, 5 installations. So I'm not buying that
Maybe
many.
Jorge. Okay. All right. There are a couple.
5.
All right. This is good data.
And I don't expect that many. I mean, it's a hobby for me, you know. So I still earn my money with big irons.
Yeah, interesting comments to be read on this too. Well, I think a lot of the stops along the way that Chip will be doing will be useful for this.
Yeah,
So the RAM file system and the SD driver, USB.
Yeah, and something for the P2 Edge with RAM.
Yeah.
Kind of a file system for the RAM, maybe. Maybe Chip's flash file system could also adapt to the RAM of the Edge. That would be interesting, I guess. To have that file system he is building on flash also work in the Edge RAM.
Terry, do you want to share what you've got today?
Sure. Let me see if I can.
Right.
So, let's see here. How can I share my screen?
You should have freedom to do that.
And it looks like John has one too, Ken.
Oh, okay. I'll let you guys just go on then. I have to take a call, so self-manage yourselves.
All right. I will try and figure this out. Share screen. Oh, big green button right in the middle. There we go. Okay. So I hope you guys, can you guys see that? See my screen?
Looking great.
Okay, awesome. So what we have over here, we have the light controller that you guys keep hearing me go on and on and on about. And I was just going to show, wow, I don't know if you guys can see the big ugly bar that's right there. Do you guys see that? I'm going to try to move it over to the other screen. Has a thing that says leave meeting. All right, there we go. Okay, so yeah, so this is the light controller, and I was just going to show the upgrades. Now, I don't know if this is going to work. I have no idea if this upgrade is going to work or not, because this is an SD card that I had laying around and that has like the previous version of the light controller on it. And so if I go over to the config screen, it's probably going to take a second to pop up, because I'm not sure if it's doing ARP announcements and everything. It takes a moment. There we go. So on the config screen, it will show you how long it's been up and the version that it's running. And it checked in and it says, hey, there's an upgrade available, because it reached out to the internet. It checked the manifest file. The manifest file shows a new version available. And so I'm going to walk through. I'm going to click upgrade. And so here's my manifest file. It shows all of the new files that are available for the firmware for the Blitzen 24. So I'm going to tell it to go ahead and upgrade my controller. Now this is all happening on the P2. This is all P2 right here. So it's downloading the boot image and all the HTML files that are associated with that. And if you'll notice, it's updating real time on the screen.
Mm-hmm.
So what I did is I figured out how that I can flush the output of it as it happens and flow that into the browser. So it makes it you can see immediate feedback whenever something goes wrong. Now it's on that GFX raw file right there, and that's going to take a minute or so to download. With the controller, whenever it boots up, oh no! See, I knew it could go bad. So it's going to try and download it again. It tries 3 times. Whenever the controller boots up, it will take a moment and let the network settle. And what I wound up doing is I wound up putting a small video that plays on the screen that you see over there whenever it comes up. And so that's sort of the, okay, I'm going to play this video, let you know that it's booting, but what it's really doing is just waiting for the network to settle from the time it turns up. And these the interesting thing that I really like about the controller that I've built here is a lot of these light controllers, they're all built on ARM, and it takes a long time for those things to boot up. You power cycle them, it takes, a couple of minutes before they're actually ready to go. And with the P2, it's instant on. Okay, looks like it tried again, and the retry was successful, and it moved all the files into the backup folder in case things go bad, and moved all the download files into the production folder, or root of the file system. So if I click reboot, hey, we've got our little reboot spinny screen there. Oh, it rebooted the P2. And oh, look at there's the video that it's playing. So right now it's waiting for the network to settle, and comes up with the little logo there, and poof. And we should get a redirect here in a moment. Oh no. Oh, there it goes. I need to get the timing on that a little bit better. And now we are up to date, and we're on the new firmware, and it's been up and running for 21 seconds since the P2 first powered on. So
very nice.
So that's what I wanted to show, that I know that there's not a lot of push from folks on the forums and everything to boot from SD card. I know there are a handful of us out there that are championing that, and I just like to show that the value in that is you can ship off something like this right here out to a customer, send them an SD card, and it has everything they need to boot up right then. And you can build a mechanism where they can update it remotely and not have to have anything other than a web browser to connect to it and make that happen. Anyways, just wanted to show that off. That's something, man, I spent a lot of time since Christmas making that go.
Very cool.
Thanks.
I guess the thing would be if this stuff like the video file, you could probably just check that if you've already got the same one, you don't have to download it again.
I've
that will
thought
require
about
some sort of versioning that's more complicated.
Yeah, that's exactly the reason I didn't do it. It's like, okay, we'll just wipe everything off of the SD card and put it over into the backup folder, and move the new items out into the root of it.
The other thing is like the fastening of the SD boot. I guess my idea would be to just have a better SD boot on the flash or something. Because the problem with the built-in SD boot is if it fails, it just the whole system is just dead, right?
True. And so then you would have to send them a new SD card.
What I do is I just you could maybe have like the most a very trimmed down version of your application that's doesn't have any actual functionality but has the ability to format the SD card or whatever, and have that in the flash.
Yeah, I've seen the stub that you built for doing that type of thing, and that's.
I mean, the stub it doesn't do anything that the normal bootloader doesn't do. It just does it faster.
Yeah, I've got no objection with that. I think that's a good way to do it, especially.
What I mean is if you have your thing that upgrades from the browser that can flash the SD card from the browser, what you could do is strip out all the actual useful code and just have the updating thing, burn that on the flash, and if someone like loses the SD card or it goes bad, it can just install itself again with all the stuff that it needs.
Right. Yeah, agreed. And the thing that I had to do to kind of cheat is I had to reinitialize the card, or reinitialize it talking to the SD card to make it to where I could get the P2 to reboot. That was the difficult thing that I ran into, at least using the version of SD SPI and FAT32 that I'm using on this, because otherwise you can hit the reset button, you won't be able to get it to reboot just because one of the lines gets pulled high on the SD card.
That's strange.
I was able to get around.
I think I always had it booting if I have the card mount. I don't think I've tried it with the SD SPI stuff. I think I've only tried it with the FlexBin thing. That reboots fine from just running, but it takes like forever to do it, of course.
Yeah,
as usual.
With SD SPI and the version of FAT that's on there, it didn't do a whole lot whenever you would dismount the card. And so what I did is I made it go through everything that it was ready to do to dismount the card, and then had it run I think it's a command 0, whatever the initialization is. And whenever it did that, then I could have it execute the reboot code. I think I'm doing it in
what brand of SD card are you using?
Cheapest thing I could find on on Amazon.
That's usually a problem. That's like cheap SD cards always cause like strange issues. Just buy SanDisk. I have not paid to say this. I only have a gun pointed at my head by Mr. SanDisk. Buy SanDisk or he will pull the trigger.
Yeah, I've used SanDisk. I've used all kinds of just junk SD cards. Most of them 32 gig or larger, and I haven't had any problems except for one. It was really weird because I had to use the SD card formatter to get it to come back to life and be able to boot again. Just performing using any of the Windows tools was useless to try and make it bootable again. It was one of those things to where I even got a tool that I put on here so I could look and see what's actually on the SD card and click through it, and I couldn't see anything unusual. I'm sure that it's some little one-off that occurred where something wasn't aligned exactly correct after I did the upgrade. But I got to say, I mean, that was after, man, I've probably done it 100 times. sitting there trying to get that process perfected and everything. And so, of the times that I've ran this process, I've had one failure, and I've done it 100 times. So 1%
that's
failure
a 1%
rate, I think,
failure. Yeah,
yeah,
that's probably pretty good.
I think that's acceptable. In my opinion, P2 boots reliably on this stuff. I don't know. I'm happy with it. I'm happy with what I've got. The only thing I would want is to have it where the reset would actually power cycle the SD card. That's the only problems that I've ran into.
Yeah, I think the only solution to that is just power cycle the card manually. I don't think doing it automatically on reset works, because if you do a soft reset, then what?
Well, what I'm saying is, if it's locked up, you want to be able to hit the reset button on the edge, and it power cycle everything.
Seems rare to me, unless your actual application has done something, ran into a wall, in which case you should power cycle it probably anyways. I don't think I've ever had it just randomly glitch an SD card. And I mean, I've
haven't
done
either.
Weird things.
Yeah. Yeah. I've done a fair amount of abuse myself, and haven't had any problems, at least with the libraries that I'm using.
Also, I don't remember if I did this in the SDSPI when I participated. If you ever have an issue where you try to read something from the SD card, but if you haven't done it for 10 milliseconds, it will be really slow. There's actually a solution to that, and it's to just keep the select line asserted at all times. That sort of keeps it awake and it doesn't go to sleep or whatever it does. Maybe it goes home, visits the family. We don't know what it does. If you keep the select line asserted, it doesn't do that. Weird wisdom that I found out.
Okay, well that's all I wanted to share, was just show that's just something I've been working on, and I'm just really pleased with how well it's working, and I'm glad it worked live. That never happens.
Thanks, Terry.
Also, speaking of silly things that I've been working in 3 giant quotes, because it's basically just it's just the fattening where you futz around with something, and that's the I've tried to get some of the old P1 games to work on P2 just for the reasons of I can do it. It looks like this. You can make it play. It has sounds. It has tank. This is one that JT Cook wrote at some point. One where you go stab like this, and while you stab, you have to enable the epic noise not reducting mode. You just go stab basically. And this was for P1, and through the magic of the flex spin ability to compile spin 1 on P2, I've made it happen on P2 for no particular reason. Other than I thought it was funny. And you can stab people on your P2 now.
I have to ask, how difficult was it to get the P1 program to compile directly on P2?
Turn the music off because it's too loud. It was the actual program doesn't need much. This particular one, I had to check. It used to load a lot of stuff from the SD card, but not that much, too much that it wouldn't fit in memory on the P2. So I had to change it all to load directly from memory, which also is the reason why if you change the screen, it doesn't take a second to load the next screen. It just does it. The actual game code, not very difficult. The actual rendering code, also not very difficult. The most difficult thing was getting it to work with Roger's video driver, because that's makes your brain hurt. And especially the synchronization, which makes brain hurt. And and also if you die and it goes black. On the original, it took quite a couple frames to make everything go red, because it very slowly loops over all the graphics and makes them red. Or like when it does a fade out, that sort of thing. It does it way too fast on the P2 compared to the original, which I guess is, you can have an opinion on whether that's a good thing or a bad thing. The whole thing where it doesn't take a second to load a new tile set and the music kind of glitches up while it does that when you like enter a cave. That's perhaps a good thing that it doesn't do that anymore. I mean, this game is really basic. You just stab people and like collect treasures. It randomizes where they are, so it's like not completely bullshit, but it's very basic. But it has good graphics for P1. Oh, someone in the chat asked to support my own game over. It kind of have. It's kind of busted and it's also not very fun. Well, which of my games? I always assume which one is meant, but if you mean the funny one, let's see if it loads. No, well, that's not necessarily a port from P1 to P2. It's more like a port from Funny Virtual Machine to P2, as much as it is a port from Funny Virtual Machine to P1. The Virtual Machine just happens to match up with what the P1 does very well. If I can get it to build a version with NTSC output so I can capture it,